Hello Basement Programmers, and welcome to the basementprogrammer.com YouTube channel. This is Tom from basementprogrammer.com. In this episode, we're going to talk about the Lambda Annotations Framework for .NET. This is an exciting development for Lambda, as it allows your developers to jump into Lambda coding while not necessarily having to understand the entire Lambda programming model. It greatly simplifies your Lambda programming and lets you focus on the high-value code. So what exactly is the Lambda Annotations Framework for .NET? Well, the goal of the Annotations Framework is to help make writing Lambda functions feel more natural for the C# programmer. Now, if you're like me before I joined AWS, you probably spent a lot of time cutting C# code for business applications. Now, in a lot of cases, this code may have been done as some kind of web app, or it may have been embedded in an API. In these cases, you more or less have complete control over the code you're writing and how it integrates. In another case, you might be extending the functionality of an application. So you might be writing a class that implements a function delegate, for example, or you might inherit an interface and be implementing specific methods. Each of these methods is fairly routine for the C# programmer and extremely common approaches for me in the applications that I was developing. Now, coding Lambda is a little bit different because there is this entire opaque service that's designed to run and execute your code inside of its own execution environment. On top of that, Lambda sometimes runs asynchronously or as part of a polling service, which means you have even less visibility as to what's happening. This means there's a learning curve to get up to speed on with Lambda programming and understanding that model. Your Lambda code is part of the Lambda service, and some aspects of the way your code runs may not be quite what you're expecting. For example, how do you get the parameters to the function that are passed as part of the HTTP query parameters? How do you wrap up your return code from your function into something that Lambda is going to understand? And potentially, how do we reuse some of the code that you may have already written to do the business logic that you now want to be part of your Lambda function? In this video, we're going to walk through the process of creating a Lambda function in .NET 6 using AWS SAM. Now, we're going to use SAM because it's the easiest way to build serverless applications, and quite frankly, it's also my favorite. However, the Annotations Framework is a NuGet package, so you can use it outside of AWS SAM for any means that you choose for creating .NET applications. So a couple of prerequisites before you can really get started using this video. First, obviously, you're going to need an AWS account. You'll need an IDE that you are comfortable with. Now, in my case, I'm using Visual Studio. You can easily use Visual Studio Code if you prefer, or any other IDE for writing C# code. I do have the AWS command line installed. I always have that installed on my development machines. And I also have IAM credentials so that I can access my AWS account from the command line. And finally, because I'm using AWS SAM, I have the SAM command line tools installed on my machine. The SAM toolkit will help me create my project structure and test my application locally. We can also use it to deploy our application into AWS as well as next steps. Our use case of this video is going to be extremely simple. I want to create a Lambda function, and that's going to be accessed via API gateway. And it's going to return some data to the caller that's based on the query parameters that are passed in. Now, for my purposes, the internals of the function are going to be extremely simple because I'm not teaching you here to create a really useful Lambda function in this video. I'm just teaching you how to wire up that function using the .NET Annotations Framework. All right, so all that said, let's get to the code. Okay, so in this first video segment, I'm going to create the project using AWS SAM, and I'm going to get the starter function set up with the internals. I'm also going to do a quick test so we can see that the function is actually executing properly as it would inside of the Lambda runtime. Okay, so here we are on my development machine, and we're going to get started with the AWS SAM project, or Serverless Application Model. I'm going to create the project by using the SAM init function. And this is going to give me a couple options. I'm going to choose one for the AWS Quick Start templates. I'm going to use the Hello World example because that's going to get me enough pieces in place that I can start working with this. Now, the most popular runtime package type that it's going to offer here is to use Python and a zip type deployment. I'm going to choose no because I don't want to use Python here. Now I get presented with a bunch of options for the different runtimes. These are all the managed runtimes that are available. I'm going to choose one for .NET 6. And I'm going to choose one for zip. Now we're given an option here as to whether or not we want to enable X-ray tracing into our application. This is going to allow the Lambda function to interact with the AWS X-ray service that provides a bunch of logging and tracing into your applications. So it really is helpful for figuring out, for example, if your Lambda runtime is taking a long time, if your Lambda project is taking a long time to execute, where is all that time being consumed? And it really helps you to see where the bottlenecks are and address them. I'm going to choose yes. Just be aware that X-ray does have some additional costs associated with it, but it's highly valuable for that development type of workflow. And now I'm going to be asked to give a project name. Okay, I'm just going to call this annotations. And now we're going to get a clone of the project going. And what this is doing, this is going to GitHub. It's grabbing the samples or the templates and downloading them to your machine and using that to build the local project. Now, as you can see, it doesn't take terribly long. And then we get the results here, the output directory, the application template, etc. There's a bunch of suggestions for commands that we can use. One thing that's always helpful, as soon as you download that project, do a SAM build. And this is going to help to, change the directory and then do a SAM build. And this is going to help us to make sure that everything is in place, that there were no issues that were found with the template that was downloaded, etc. So you can see it's all fairly good. And then we can do a SAM local invoke. Okay, and we can see here, as a result of that, my Lambda function was actually successfully run in a local version of the SAM runtime, or the Lambda runtime. Now, you can see a report here that tells you the duration of the call, the build duration as well, and how much memory that was used. And then you get some output here. And I'm going to show you the code in just a minute. The output is a simple hello world function with my IP address shown that I will probably block out for this video. So now we've used SAM to create that basic project structure. So the next thing we're going to do is dive into that code. So I'm going to start Visual Studio. And I am going to open the project. Okay, once I'm in the folder that I created my SAM project, I can see there's a few folders here, events, source, and test. Source is the actual project that was created. And I can see here there's a C# project file available. I'm just going to load that. The other thing I want to do is I'm going to grab this event file and I'm going to open that in Visual Studio as well. Okay, what you can see here is a JSON file, and this is a sample of the JSON that is passed into your function when it is executed from the API gateway, the AWS API gateway. Okay, and so this is how you would create an API that's going to be published out to the world. Typically, as we saw in the slides before this, we've got the API gateway, and that's going to execute our Lambda function. Well, this is all the this is the body of the event data that gets passed in, and you can see there's a bunch of different things here. There are the HTTP method, your path, resources, the headers that are pushed in, and a bunch of other options here. Part of that is going to be here, the query strings. So this is going to be the values that get passed into the query from the caller through API gateway. It appears here in these query string parameters. So I'm going to set this up just quickly. Value 1. Hello. Value 2. Okay, and I'm going to save. Now over here in my project, you can see there's the function.cs file, and that's what I'm going to open up here. Now the entire definition of this sample Lambda function is pretty simple. We have here the function handler, and this is actually the body of the Lambda execution. And I've got a helper function here just called get calling IP, and that's going to reach out to the internet and check what my IP address is and send it back. All right. Now, in order to understand the way that Lambda works, we have to look here. This function is designed. There is in this case, the API gateway response is the response type that we are sending back to API gateway, and you've got a function handler here, which is the API gateway proxy request and the Lambda context. So all of this stuff gets wrapped up, and you really need to understand the way these items work in order to effectively build that, in order to effectively interact with Lambda. Now what I'm going to do here is I'm going to retrieve those two values that I have set up in the calling event. Pretty simple here, and then what I'm going to do is string message equals. So here what I've done is I've retrieved those query string parameters that are defined here, so value 1, value 2. I've done a simple string format, and then I'm going to use the console write line method in order to write that out to the console. Now, when I am running Lambda in a debug mode, like I'm doing here in my application on my local machine, the console is going to go to, obviously, the console. So it's going to write out, and we'll be able to see this on the command line. However, if I'm writing a Lambda function I'm executing inside of Lambda, the console actually gets routed out to CloudWatch. So it gives us an easy way to do some fundamentally basic logging that works both in debug mode and up in the Lambda service. Okay, so all of these console write line commands are going to go into CloudWatch and be ready for us. So I'm going to save this. I'm going to jump back to the console here, and I'm going to do SAM build. Once again, I'm going to rebuild my project and get that ready for deployment as a Lambda. And now I'm going to do SAM local invoke. However, I want to pass in the event data to my function. So I do that with a -e, and then events slash as you can see here, it's from my project folder, it's the events subdirectory, and it's event.json is the file that's being passed in. Okay, we can see here the parameters are hello world. Okay, so very basic example. But as you can see, in order to effectively use Lambda in this context, you really have to understand quite a bit about the way we're interacting. We're using the API gateway proxy request. We're returning this API proxy response value. We need to understand how to get at these parameters. And if we look at this code, it's not something that we would imagine has been able to be used someplace else in our development cycle. This isn't something we're going to have already written to handle that business logic. So how can we make this a little bit easier for a new developer to come out and say, this is what I want the result to be? Well, we can get to that in just a second. The next step is to change my application to use the Annotations Framework. This is going to greatly simplify the code that I need to write. And you'll see as I do the testing that it gives us the same result. Okay, so we're going to jump back into my development machine, and we're going to go back into Visual Studio. Now you can see this is the same project that we were working on before with the Lambda programming model. But we want to try to take advantage of the Lambda Annotations Framework to really simplify the code. So let's go here. I'm going to add a new project. Okay, and from my project templates, I'm going to select a serverless application. So AWS Serverless Application, .NET, and C#. Obviously, C# being my language of choice. Okay, so I'm going to hit next, and project name. So I'm just going to keep the default here, AWS Serverless 1. And I'm going to hit create. At this point, I get the option to choose a blueprint. And we can see here there's a new blueprint called the Annotations Framework listed in preview. Now, please be aware, the Annotations Framework, it is still in public preview. We're actively looking for customers to actually take this, give it a try, see how it works, and try things out on, for your environments, and provide us feedback. This is fairly late in the piece, so we've had a lot of work done. We've had a lot of feedback. But we're really trying to get some more customer feedback on how well this works for them. So I'm going to select Annotations Framework here and click Finish. And this is going to go and create my new project. Okay, and we can see here there's a serverless template file that is set up. Gives us some of the bits for that are pre-configured, a README, and of course the function. Now we can see here the functions actually look very different. So we've actually got quite a few sample functions already put here, and we're going to delete most of these because we're not really that interested in having a whole bunch of functions for our use case. We've only got one, so let's do here, and we're just going to leave these two here, the default get and the add function. We're going to rename those in just a minute here. So you can see right away the programming model is actually quite different. We've got public int. We've got a function that looks very much like a typical function that we might have in place in our code. So we don't have the Lambda request objects and the response objects that can confuse new programmers. And we're doing a simple return case. So in return x plus y. Okay, so let's have a flick back here to function. I want to have something that's very similar in nature to the function that I was coding here in the other programming model. So I'm going to grab this here, value 1, value 2, here, and my Lambda output. Copy those, and let's close these files so that I don't get confused. Go. I'm going to change these to be strings. And I'm going to have a return type of string. And what I'm going to do is say return message. Okay. Now obviously I don't need to retrieve these values from the API proxy event because we don't have that object. We're simply getting those passed in here. And let's change the names. The other thing I want to do here is I just want to change these to match up. And I'm going to eliminate these commented out lines to make the code a little bit cleaner. Now, the other thing I need to do over here, I'm going to jump to the serverless template, and you can see there's a resources element here. Now, there's a bunch of functions that I had deleted, the subtract, multiply, and divide, and I'm going to wipe out those there. Look at the definitions here, and so I have x and y, which are my old values. Update these just so everything matches up. Okay, another thing I want to do, obviously I want to set the startup project to be my new project. Okay, so now that we've made all these changes, we've got everything lined up. So we've got our public string add, in this case, value 1, value 2. The function body looks just like something we would normally code without any knowledge of Lambda. The only additional thing that's been added really is this Lambda context value. So it's now time to actually test this out and see it in production. So what I want to do here, I'm going to go and I'm going to say, go to my serverless project, and I'm going to say publish to Lambda. Now I'm going to give it a stack name, and I'm going to deploy to US East 2. And you can see here, the bucket that I'm using, that I'm deploying my assets to, is going to go to US East 2. I've just reused one that I've used for some CDK projects. And I'm going to hit publish. It's going to publish up the zip file. So this is going to zip up all the assets. It's going to build all the assets, build the function. It's going to zip it up, and it's going to send it up into that bucket. And now we've got the standard deployment process for a Lambda application. Yeah, and what we're actually seeing here, I've talked about several times how all of the different deployment methods really come down to CloudFormation in the end of the day. So you can see here, this is actually just CloudFormation that's running, and we're getting a display of the CloudFormation output live as it's going along. So these are all the messages. We'd be able to see those in the console if we went and looked. This is going to take a few minutes to complete. We can see the status here, create and process, and it's done. So what's happened, because we've created a serverless application, this has gone and created an API gateway for us. It's created the Lambda function. It's created all the things that we need to tie these two bits together and publish them for us. And now we've been given this serverless URL. So I'm going to hit copy there. Okay, now you can see as I hit this, we're actually getting just a sample output here, which describes the original methods that were in the template. Okay, and I didn't change that, so these details are actually incorrect. You can see that it really just aligns to, this default text that's been put here. But what I'm really interested in is testing my function here, my business logic, as simple as it is. So what I'm going to do is I can come here, I can say add hello world and hit enter. And once I hit that, you can see the return code is hello world. Now, if you remember back in my function, all I'm doing is grabbing the two parameters and concatenating them, so value 1, value 2, and sending them back. So obviously, I could say change hello world to hello basement programmers and get that result back as well. Now, that on the face of it, returning a simple string doesn't really sound like that much, but consider the code differences between what I've written here, which is really just the core business logic, and what I had to write here. I had to understand the entire Lambda programming model in order to make anything useful. Whereas here, I've simply got my standard function. You can imagine this is very similar or the same as the code that you might have written as business logic for your application when it was running on premises or running on an EC2 instance. The only thing I've had to do is decorate it with a few attributes here and add in this one extra parameter, which is the Lambda context, which is obviously going to be used. All the rest of this, I'm accessing methods exactly as if they were standard parameters, and I'm returning a standard parameter, which is just a string. And I can make this into anything I wanted to. Now the attributes here are going to take care of doing all that wrappering and making sure that the text that goes back is an appropriate response for the caller. So you can see that obviously the code is much simpler, it's much more streamlined. So as always, the source code for this project can be found on GitHub. It's going to be github.com/basementprogrammer, and the project is called Lambda Annotations. Thanks for watching. If you like this video and you find it useful, please consider subscribing to my channel so you can get updates as I create more videos. Also, check me out on the Basement Programmer podcast. If you have any feedback, feel free to post some comments or drop me an email. It's Tom, that's Tom, @basementprogrammer.com. I'd love to hear from you.